Hello teacher, hello students, welcome to today's lesson on the method of development. In our last lesson, we have seen the use of surface development, the different types of surface and solid, the types of hem and joint used in a sheet metal drawing, and the principle of development. Let's briefly revise the previous lesson as usual. There are developable and non-developable surfaces. A developable surface is one which may be unfolded or unrolled so as to coincide with a plane. Surfaces composed of single curved surfaces or of planes of combination of these types are developable. Wrapped surfaces and double curved surfaces are not developable. Development is a graphical method of obtaining the area of the surface of a solid. When a solid is opened out and its complete surface is laid on a plane, the surface of the solid is said to be developed. The figure thus obtained is called a development of the surface of the solid, or simply development or a pattern. Development of the solid, when folded or rolled, gives the solid. Knowledge of development is very useful in sheet metal work, construction of storage vessels, chemical vessels, boilers, and chimneys. In our today's lesson, we will discuss the rules and steps of parallel line development and the development of prism using parallel line development. There are two principal methods of surface development. These are the parallel line development and the radial line development. Parallel line development is used to develop prisms and cylinders using the stretch out line. On the other hand, radial line development is used to develop pyramids and cones in which the true length of the slant edge is used at the radius. We will talk about radial line development in our next program. Parallel line development is a simple way of making a pattern. It's done by drawing the edges of an object as parallel lines. The figure at C is a pictorial view of cylinder. At D, a pattern for the prism is made by a parallel line development. Students, there are different kinds of prism: rectangular prism, truncated prism, and oblique prism. We use somewhat different steps to develop the pattern of these prism types. We'll discuss the development of each prism type one by one. First, we'll see the steps used for making the development of a rectangular prism. In order to develop the pattern of a rectangular prism, we should follow the following steps. Draw the front and top views of the prism. On the top view, number of the edges in the clockwise direction so as to ensure the development will be made inside app. Also, number the edges on the front view in agreement with the numbering on the top view. Construct the stretch out line through the base of the front view. Transfer the width of the faces from the top views to stretch out line, locating points 1, 2, 3, etc. on the stretch out line. Draw lines perpendicular to the stretch out line through point 1, 2, 3, etc. Transfer the true length of the edge of the prism from the front view to the corresponding line on the development, locating points 1 prime, 2 prime, 3 prime, etc. To do so, you may use either projector or your divider. Complete the development by joining points. Also, attach the lower base and the upper base of the prism to get the development of the entire surface of the prism. Well, students, let's do an activity to check how much you understood the lesson. The views of a rectangular prism are given on the screen. Make the development of this prism correctly. Don't forget to use the steps you have learned. Welcome back. Did you complete the exercise? I'm sure you did. The solution to the activity is given on your screen. Students, how are you doing so far? I hope you are doing great. Next, we'll discuss how to develop the pattern of truncated prism. Do you know what a truncated prism is? Let's see. A truncated prism is a prism which has one base cut off by an inclined surface. In order to develop the pattern of truncated prism, we should follow the following steps. Draw the front and top views of the prism. Also, draw the auxiliary views of the inclined surface. On the top view, number of the edges in the clockwise direction, starting from 1 at the shortest edge of the prism. Also, number the edges on the front view in agreement with numbering on the top view. Construct the stretch out line through the base of the front view. Transfer the widths of the faces from the top view to the stretch out line, locating points 1, 2, 3, etc. on the stretch out line. Draw lines perpendicular to the stretch out line through point 1, 2, 3, etc. Transfer the true length of the edge of the prism from the front view to the corresponding line, locating points 1 prime, 2 prime, 3 prime, etc. To do so, you may use either projector or your divider. Complete the development by joining points 1 prime, 2 prime, 3 prime, etc. Also, attach the lower base and the auxiliary view of the inclined face of the prism to gauge the development of the entire surface of the prism. Well, students, here is a practical activity for you. The views of a truncated rectangular prism are given on the screen. Make the development of this prism correctly. Don't forget to apply the steps you have learned. Welcome back. Did you make the development of the object correctly? Wonderful. The solution to the activity is given on the screen. Well, students, how are you doing so far? I hope you are enjoying the lesson. Next, we will look at the development of an oblique prism. Do you know what an oblique prism is? Let's see. An oblique prism is a prism in which the bases are not aligned properly. In other words, if the joining edges and faces are not perpendicular to the base faces, is called an oblique prism. In order to develop the pattern of an oblique prism, we should follow the following steps. Draw the front and top views of the prism. Also, draw the right auxiliary section of the prism. Number the edges of the prism on all views. Construct the stretch out line at any appropriate position. Transfer the width of the faces from the auxiliary section to the stretch out line, locating points A, B, C, etc. Draw lines perpendicular to the stretch out line through points A, B, C, etc. Transfer the true length of the edge of the prism from the front view to the corresponding line, locating the endpoints of all edges on the development. Complete the development by joining the endpoints of the edge and also attach the lower base and the upper base to get the development of the entire surface of the prism. Well, let's strengthen your knowledge of developing the pattern of oblique prisms by doing an activity. The views of a rectangular oblique prism are given on the screen. Make the development of this prism correctly. Don't forget to follow the steps you have just learned. Welcome back. Did you complete the exercise? Excellent. The solution to the activities given on the screen. Well, students, I hope you have gained a lot of concepts from today's lesson. Before we come to the end of the program, let's summarize the main points. Parallel line development is a method used to develop prisms and cylinders. Developments of objects with parallel elements or parallel lateral edges begins by constructing a stretch-out line that's parallel to a right section of the object and therefore perpendicular to the development of a right rectangular prism elements or lateral edges. In the front view, all lateral edges of the prism appear parallel to each other and are true length. The lateral edges are also true length in the development. The length of the stretch out of the development is equal to the true distance around a right section of the object. Well, students, that brings us to the end of our lesson for today. Keep on practicing on the parallel line development method. In our next lesson, we will learn about the development of cylinder using parallel line development. Until then, thank you, teacher, and thank you, students. Goodbye.